Hello, everyone. Thank you for joining us for our next session of our weekly Wrangling Rag workshops, Improving Rag. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It'll be available to view on demand within 24 to 48 hours. With that, I will turn it over to our presenter. Thanks so much for joining us.
Hello, everyone. I don't know if you can hear that in the background. It's the fire alarm. Yeah, so my name is Yujin. I've been building a bunch of RAG applications. I'd love to know where you guys are coming from as we kind of, let's kick off this show. Anna, can you put the slides up? Okay, great. Someone says, hope you are safe from fire. Yes, they're testing the fire alarm this morning. We're in like the pre-stream, like, I don't know, whatever, like room, and like the fire alarm went out, and I was like, oh boy, I have a fire alarm, but it's just the test. So today we're going to be talking about improving RAG. So we're going to cover some things that we've covered in the basic RAG workshop. We're just going to cover what RAG is, what are the pieces of it, and then we're going to go into how you can improve it, and we're going to go into a workshop on how you can use evals to make your RAG applications better. If you have any questions, please feel free to drop questions at any time in the chat. And every so often, I will go back to the chat and read some questions and see if there's anything that will be pertinent to answer. So the content of this slide deck is basically just going to be a RAG review and then talking about what makes RAG better. We're going to go over some concepts and some things like that. And then there's the fire alarm again. And then we're going to go into the workshop. Okay, I think it's just the. Okay, it's gone. Okay. All right, so what is RAG? RAG is basically a way to give your LLM access to your data. RAG is retrieval augmented generation, and LLMs do, generative AI. And so RAG, as the name would imply, is that you augment the way you generate your text or images or whatever, the way you generate your output with some sort of retrieval. And the retrieval that's done is over a vector database. So this is the general setup for a RAG application. A RAG application, on the bottom, you can kind of see the setup piece of the RAG application. On the top, you see the usage portion of the RAG application. So on the bottom, you take the data, you put it into an embedding model. The embedding model can be an LLM, may not be an LLM. In this example, I'll talk about what we're using in this example later on. And then from the embedding model, you take that embedding and you put it into a vector database, and that's your setup. Your setup is you have your data, it gets embedded, and the embeddings are stored with some metadata into the vector database. And then when you're using your RAG application, when you're performing retrieval against this kind of data, you are taking your query, that's the query piece, and you're sending it to an LLM. And the LLM is going to then take that question and try to find the relevant answer, or like something similar that needs to answer from that question, send that to the embedding model. The embedding model is going to embed the data, the question, the answer, the LLM mishmashed text, and it's going to send that to the vector database. And in the vector database, we're going to find like the top 3, top 4, top 5 most similar responses in terms of embedding, in terms of semantic embeddings. And we're going to return that to the LLM. And then the LLM is going to take that, format it, make sense out of it, and return that back to you as an answer. So the tech stack for creating these retrieval augmented generation applications are some sort of LLM. You can use an open source LLM. You can use GPT, which is the most popular LLM. something like that. And then you can use a vector search engine, an embedding model, and some set of frameworks. The frameworks are optional for proof of concepts, but uh, they're very useful for when you're starting to build out larger applications. Sometimes you kind of go the other way around. You use a framework to build a proof of concept, and then you want to customize how things work, and you discard that framework and customize it yourself for production. You'll notice here that I did not write vector database. I wrote vector search engine, and I did this on purpose. So um, I have been talking about this for a while now, but vector databases are not real databases. Vector databases are a search engine, a compute engine that sits on top of a real permanent storage layer. But vector search engine is a much longer word to say than vector database, and it doesn't. People tend not to click with that as much. Okay, let's see. All right, so we're going to cover some of these technologies and how they work. If you have any questions, I'm going to check the chat now. Okay, I don't see any questions about this so far, so I'm going to go on. If you have any questions, I'll be checking this chat back in a few minutes. So the first thing we're going to look at is the LLM. So in the last workshop, we kind of went through this history of neural networks, from basic neural networks to RNNs for sequential inputs to transformer models into these decoder-only models, which are LLMs. And not all LLMs are decoder only. This is specifically from GPT. And basically what this does is it takes some sort of tokenized input that contains a tokenized version of where you are in the text, where you are in the context window, as well as the total context that's been passed in so far. And so part of the reason why it does this is because transformer models, these encoder decoder type architectures, solve this problem of lack of long context, right? So traditional neural networks have this issue of vanishing gradients where they will lose context over time. And so you can only have sequences that are so long. And so encoders make that much easier to expand the length of that sequence by encoding not only the current token, but the context along with it. And so this drawing here is basically just showing you if you take some sort of inputs, the decoder will give you some sort of outputs that predicts the next X tokens, and that's it. So basically what this is saying is that LLMs are predicting the output. Okay, so let's also cover vector search. So vectors and embeddings, I've been using these interchangeably, vector embeddings, whatever. The way you think about these is these are just long series of numbers. That's really it. They're just a series of numbers. And in this example, you'll see we're going to look at this top example here of houses, puppy, dog, and cat. And basically what this is showing you is the closer these words are in semantic meaning, the closer their vectors are, like in a quantified manner, right? So you'll see that puppy and dog are really close, and dog and cat are pretty close, but cat is further away from dog than puppy. And that's because puppies are closer to dogs. Like the concept of puppies is closer to the concept of dogs than the concept of cats. And you'll see that all three of these are even further away from houses than dogs and puppies are from cats, because houses are less like related to puppies, dogs, and cats than they are to each other. So vector search is basically just a way to quantify these differences in semantic meaning that we as humans already kind of qualitatively know. Okay, and so embedding models are just models where you have some sort of text or image or whatever, and you put it into the model and it spits out some sort of numbers. This is the vector embedding. So embedding models are what transform your unstructured data, your text, your images, video, audio, whatever. They transform that unstructured data into structured data, which in this case is vector embeddings, which is just a list of numbers. Okay, let's see if there's any questions so far. I did not mention DBT. I said GPT. I might sound like DBT because of all the weird noise happening here. But GPT as in generative pre-trained transformers from OpenAI, which we'll be seeing later. Okay, so how does semantic search fit in RAG? So semantic search is the part of like that's what vector databases do. Vector search engines do. They perform semantic search, right? So what they do is they actually compare these. What they're doing internally is they're comparing these embeddings, these quantified values, but qualitatively, what they're doing for you is they are doing the semantic search where they are comparing the meanings which are represented by these numbers. They're comparing the meanings of two different words. So that's how semantic search fits into RAG. And basically, you ask the question, it does some sort of semantic search in the vector database, it returns some responses, and then you get the response from that. So for for the last workshop we did, the basic RAG workshop, we had Octo AI for LLMs, we had Face for our vector search, we had Hugging Face for our embeddings, and we had LangChain as our framework. And we're just going to build off of that today. So this is what the architecture looked like for the last one. Basically, this is the exact same picture that I showed earlier, except now you've got a outline around the LLM, the embedding model, and the vector database. And you see that there's like the LangChain logo in the middle. We're using LangChain to orchestrate this. Now, LangChain isn't the only thing that you can use to orchestrate this stuff. You can use Llama Index for some other things, and maybe in the next few workshops, we'll do something like that. But this is just an example of a RAG architecture. So Octo AI is a LLM, is a company that provides compute and LLMs and a bunch of other things like media generation and stuff like that. And they use a bunch of open source LLMs like Llama 3 and Mistral. These are very popular. And then Hugging Face is a model hub that provides a lot of embedding models. And Hugging Face is like my favorite model embedding hub. In fact, they're probably the only model embedding hub, embedding model hub. I mean, they have hundreds of embedding models you can get for free. So really great. And FACE stands for Facebook AI Similarity Search. And this is a similarity search engine that similarity search architecture engine framework, I guess, that came out of Facebook, Facebook's AI research labs. And this is basically what every popular vector database is built on. Like, I think pretty much if you know of a database that's like vector database specific, then it's probably built on Face. So for this tech workshop, for this tech stack, for this workshop, what we're going to do is we're going to add a evaluation framework. So we're going to add Arise Phoenix as our evaluation framework. So evals are ways that we can look into how we can improve our RAG applications, right? So the title of this workshop is Improving RAG. And this is how we look into how we can improve our RAG applications. I'll be touching on some other things as well, like chunking your data, like the chunk overlap, chunk separators, all these kinds of things as well. But primarily, when you start putting things into production, evaluation frameworks are what you need. So this is basically the same architecture, except now we're going to wrap everything with this use of Phoenix. Okay, so I'm going to pause here to see if there's any questions before I get into the concepts. Okay. So some of the concepts that we'll cover in our workshop today are LLM as a judge, which basically is when we're using an LLM to judge the output of other LLMs. We're using an LLM as eval. Relevance. So relevance is how related an answer is to the question. And hallucinations, which are when the LLM is making things up. Okay, so these are concepts that we're going to cover today. And before we dive into the workshop, I'm going to advertise my LinkedIn here. So if you have a phone, if you have a LinkedIn on your phone, you can take your phone out, scan this QR code. You can find me on LinkedIn. And if you have any questions, you can ask your questions to me on LinkedIn. So I'm going to pause here very briefly to see if there's any questions before I dive into the workshop. So I'm going to give it like in 15, 20 seconds just to see if anyone has any questions to type. And hopefully the fire alarm stops soon. Okay. I do not see any specific questions about retrieval augmented generation or how to improve retrieval augmented generation or any of the concepts that I talked about earlier. So I'm going to assume that means we're all good to dive into the live workshop. All right. Let's see. Let's make this a little bit bigger. Let's close this here. Zoom in a little bit. Can everybody read this? This is big enough zoomed that everyone can read this. Okay, I'm going to assume this is big enough zoomed that everyone can read this. If you have any questions during this, just type them in and I'll try to answer them. So you'll see that here we're actually using OpenAI and OctoAI, and you'll see why later. So here what we're doing is this setup here, these are the libraries you're going to need to run this. Now, I could have like a requirements txt for this stuff, but there's just so many that it varies in between the different what are they called? The different setups that sometimes it's easier to just fresh install these into a new virtual environment. Okay, can we use different models for generating embeddings and querying? So for generating the embeddings that you put into your vector database and for querying embeddings, you need to the only like technical like mathematical requirement that you have here is that your embeddings, your vector embeddings have to be the same size in order to compare them. So can you use different models? Yes, but there's not really good reason to use different models. The only reason you would use different models is if you're testing how models drift over time. But otherwise, I would say use the same model to generate embeddings and to generate for both like putting your data into the vector database and for querying your data in the vector database. That doesn't mean that you have to have the same embedding model as you have LLM. So the LLM and the embedding model can be different and are usually different. And you'll see in this example that they are different, but that's not always the case. Like you can use OpenAI for your embeddings and your LLM if you want. It's just more expensive. So in this tutorial, we'll be installing LangChain. Of course, since we're using LangChain as our wrapper, we'll be using LangChain Community. So LangChain Community is there. So back in the early days, LangChain created a bunch of different plugins. And then they found that like, hey, we're a small team. We can't maintain all of these. So LangChain Community was their way of spinning this out into community hosted or community maintained plugins. And then there's Face CPU. So earlier I talked about Face, which is Facebook AI similarity search. And this is a vector search algorithm. And Face CPU is the library that runs Face on a CPU. Vector search mostly occurs on CPUs, but there's some GPU compatible versions as well. So you can have, Face run on the GPU. Sentence Transformers is the Hugging Face library that basically allows you to run these transformer type models. Remember earlier in the beginning, we talked about LLMs, how GPT is a decoder and how LLMs are these encoder decoder transformer models. So sentence transformers are transformer models for NLP for sentences that Hugging Face made. And we've got the OctoAI SDK. So this is the OctoAI is basically how you access OctoAI. I think you can also just install OctoAI now. I know they're in the middle of an overhaul before, and I don't know if this has been totally changed over or not yet. I think both work right now. And then you can use LangChain text splitters. So this is LangChain's way of doing text splitting on LangChain. And text splitting is the way that you chunk up your data. And so we'll talk about chunking later on, because chunking is an incredibly important piece of basically like how your data gets stored. And then AlexML and TickToken are supportive libraries to this. Python.env is just the environment variable managing library that I use. You can use other libraries for your environment variable management if you would like. And then Arise Phoenix evals. So earlier we talked about using Arise Phoenix for our evaluation, and later on you'll see kind of how that works and what that does. And so this is the library that does that. If you're on a Windows computer, you don't need the quotations, but if you're on a Mac, you'll need the quotations. And then we got OpenAI. So OpenAI is one of the libraries that we're using here. So you'll need an OctoAI API key and an OpenAI API key to run this. So if you sign up at octoai.cloud, you'll get $10 of credits for OctoAI and get an API key. And I think OpenAI also has like some amount of free credits for OpenAI as well. So either way, if you don't have an API key yet from either of these, you can go get a free API key by signing up on their websites. All I'm doing here in this first one, okay, I think this is the right virtual environment. I'm hoping this is the right virtual environment for this library, for this workshop. So all I'm doing here is I'm calling my .env and I'm loading my .env and I'm getting my API keys stored. And now what I'm doing here is I'm launching Phoenix as an application. So later on, we'll take a look at we'll look at this in the browser, but this will basically pop off onto localhost 6006. And then in the next one, I'm going to run the LangChain instrumenter for Phoenix. So this is what allows Phoenix to know that, like, hey, we're running this in LangChain, and we're using LangChain to do this basically. So Phoenix won't always be able to keep track of your LangChain calls unless it knows, because LangChain wraps your calls, right? So the next step we're going to do is we're going to ingest our data. So here we're getting a character text splitter and a document. So a character text splitter is just a way that we split data in LangChain, and basically it splits on a specific character. I wonder if I can click into this code here. I don't know why I can't click into this library here. Usually it lets me do this. I don't know what's going on with VS Code for this, but the character text splitter library basically splits on a double new line. And yeah, document is how LangChain stores entries into the vector database, basically documents. And then in the next line here, what we're going to do is we're going to go and we're going to actually split up our data. So the way we do this is we first get our directory. And so here we're looking at this directory called city data. And I actually think it might have to, oops. I don't think, yeah. So I actually have to go up two, right? I actually have to go up two folders to city data. And then we're going to create this empty, oh yeah, I'll show you what's in city data. So city data includes a bunch of cities. These are scraped from Wikipedia. Okay, and then we're going to create this empty list here. This empty list is basically just like, it's just an empty list. And this is what's going to store our documents for LangChain to put into the vector store. Now we're going to loop through all of the files that were in here, and we're going to open them up, and we're going to read them as a string. So read turns that file into a string. So now we've got the entire file as a string. And then we're going to create a text splitter. So character text splitter, we're going to use this. We're going to create a function out of it. We're going to use the TickToken encoder, and we're going to create some sort of chunk size and chunk overlap. If you have any preferences for a chunk size and chunk overlap you want to test, drop them in the comments. Remember that chunk overlap has to be less than the chunk size, and ideally a lot less than the chunk size. So chunk size here, it doesn't really matter. We'll just pick something random. So last time I did 12, 1, 2, 3, 4. Maybe I'll do 800, maybe I'll do 200. So chunk size is just the number of characters that are in a chunk. And chunk overlap is the amount of characters that overlap between chunks. And like I said earlier, this is not a hard and fast rule because character text splitter typically splits on a double new line. And actually, in a second, we'll look at how we can change that. But for now, we'll look at this. And then to actually get the text, what we'll do is we'll just take our text splitter and we'll split these file texts. And then we're going to just iterate through all of these texts. And I'm actually going to enumerate through all of these texts so that I can keep track of what chunk num they are. So this is not actually the best way to keep track of the chunk number, because ideally you want the chunk number within a text, but this just keeps track of it in alphabetical order, total chunk number. And then inside of this loop, what we do is we're going to create this document here, and we're going to give it the page content. The page content is just what LangChain uses to store the text within to store the text for a document. Then we're going to give it a metadata title, and so we're going to give it a doc title, and then the doc title is just going to be the title of the file, and then we're going to tell what chunk number it's at, which just lets us know like roughly like where it was when we split it. So we see here that we actually get these chunks that are larger than 800, and that's because character text splitter splits on this double new line, which means it won't split in the middle. It won't say like, okay, this is 800 like characters. Like what it does is it says it's 800 characters. I'm gonna look for the next double new line that I'm gonna split. And the reason it does this is because like you don't want to split in the middle of a word or the middle of a sentence or something like that. So you want to split on like a logical semantic separator. And so what we can actually do here is we can actually say separator, and we can give it a period, and it should be a different result. In fact, it should be totally fine. Yeah. Okay, I'm going to pause here for questions. Someone says, Akash asks how to generate the knowledge base from an unstructured document that has text content as well as large tables by just using the normal method. The response we get from AI is not accurate. So to do this, you'll probably need some sort of specialized intake file. So like I would say you can use like Llama Parse. From Llama Index, they have Llama Parse, which is their like PDF parser that achieves like state-of-the-art results. You can also try out unstructured. Unstructured IO has something that does something like this. You can also try out like OCR. You can use optical character recognition to read your PDF files or stuff like that. But that's well out of the scope of what we're going to be working on today. And to be like totally honest with you, this is like not something that is very well understood. And part of this is just because like it's very hard to have programs do mixed medium extraction. But Llama Parse seems to have the best results that we see as of today. Someone says that's a ton of RAG data from Wikipedia. Thank you. It is. And actually, GPT is already trained on Wikipedia, and so is like the Octo AI stuff. So all the open source models are already trained on Wikipedia, but this is just a toy example. Like this is not like you're not meant to take this and put this into production. Someone asked, why don't you use Markdown text splitter? And then someone responded in the chat that this is a text extension, so that's why we're not using Markdown text splitter. If you have a .md Markdown file, then you can use Markdown text splitter. Okay, so here we saw basically like how to make this better, and I'm going to get rid of this for the next one so I can do it live again. Okay, so now we're going to go ahead and we're going to start adding stuff to our vector database. So what we do here is we're going to get the embeddings function, which is Hugging Face embeddings, and the vector store, which is face. So Hugging Face embeddings, like I said earlier, like this is the link chain library that basically allows you to access embedding models from Hugging Face. And so Hugging Face, like I said, the biggest model hub in the world, and also probably the most, like, I think it's probably like your best choice to get started. Like you might want to like grab an open source model from here and fine tune it for specific use cases, but overall, probably your best choice to get started. And then we have Face, which is our Facebook AI similarity search library. Probably this is like the core vector database. Now what we do here is we just call this function to get the Hugging Face embeddings as a function. And then we create the vector store, and we're going to search the documents, and we're going to create the vector store from the documents. And the way we do that is we call the from documents function from Face, and we pass in all these file texts, and we pass in the embeddings, like the Hugging Face embeddings function. And what's going to happen is that this function, this from documents function, is going to take all of these files that we created earlier. It's going to embed them with the Hugging Face embeddings, which, by the way, this is MPNet. It's going to get MPNet. It's going to embed them with the Hugging Face embeddings, and then it's going to store them into the vector store along with this page content and this metadata. Okay, let's see if there's any questions here. All right, someone's asking about Azure AI Search. Like, I don't know anything about Azure AI Search. I'm going to be honest. I actually don't work at Microsoft. I know this is a Microsoft Reactor stream, but I don't work at Microsoft, so I don't know anything about it. How to block people from doing social engineering stuff? Like, if you make the API, it gets only your data from the indexes. How do you disable them from having stuff outside of the knowledge of RAG? So that's actually going to be up to the LLM, and actually, that's going to be like that's going to be something that the LLM, you have to pick the right LLM to do that. And actually, we can test that here. We can see how well this LLM is able to not give you access outside of the city data that we have already collected. So we'll take a look at that later. Okay, so here what we're going to do is we're going to go to the OctoAI endpoint. We're going to call OctoAI's endpoint to use meta llama 3 8b instruct. So llama 3 is another, it's actually out of Facebook as well. It's very, very popular. And 8b instruct is one of the popular models, or one of the popular versions of meta llama 3. And 8b just means it has 8 billion parameters. Instruct means that it's tuned for instructions. We're going to give some number of max tokens. Like, you can really do anything you want here. I'm just going to do like 2000, whatever. And then temperature, top P, presence penalty. These are just like ways to tell the LM how creative you want it to be. Okay, so yeah, this is the model is what I intended. So this gets us the model. And then we're going to turn the vector store into a retriever. And basically what this does is this takes the vector store and it prepares it for text retrieval. So it prepares the embedding model. So it says like, hey, if you get this text, embed with the embedding model and then retrieve from the vector store. And then we're going to give it some sort of chat prompt template. So in this case, I'm going to say like, you're a tour guide, blah, 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 blah. Keep your answers at 3 sentences. And this is basically how you prompt things, right? Like, this is how you create a prompt template for the LLM. And then here we're going to create the chain. So the chain is going to require this runnable pass-through, so we can take a text and we can treat it as a function. And basically what we're saying here is we're going to get the context and the question, and here are the functions that we're going to get them from. And we're going to pass them into the prompt. And then we're going to pass the prompt into the LLM. And then we're going to pass the LLM's output into a string output parser. So we parse the output of the LLM as a string. And then we just say something like, and by the way, if you have questions you want to ask, like, this is where we get the test questions, right? So let's test at least like 3 or 4 questions here. So why don't we say like, what is a good landmark to visit in San Francisco? So normally I'm based in Seattle, but today I'm actually in San Francisco. I'm traveling for work. So a good landmark to visit in San Francisco is the Golden Gate Bridge. It's an iconic symbol of the city and offers stunning views of the San Francisco Bay and the city skyline. It's also a popular spot for tourists and locals alike, with many people walking or biking across the bridge for exercise and recreation. Additionally, the bridge is a great spot for photography with its striking orange color and dramatic architecture. Um, oh, there's a question in the chat. What's the best technique to store vectors that are generated from chunks from the same document so that VSS includes all of it when search is issued? Oh, so what you'll want to do here is actually you'll want to do some sort of metadata filtering where you say like, okay, like, um, I think what you're asking about is retrieving an entire document. So what you'll want to do is you'll want to say like, okay, like retrieve like this similar stuff, and then you'll probably have to do a second retrieval. Like not all, some vector databases might have this built in, but I haven't really seen it yet. And but what you'll want to do is you'll want to say like, okay, here's the metadata. Now I'm going to filter by this metadata, and I want this entire um, every entry with this document title to be returned to me. And that's basically how you would do it. Or you'd have the document stored somewhere and you would retrieve the text, and then you would say like, oh, like based on this metadata, like give me that entire document. So that's basically it. Let's ask some other questions to this thing. So how about, let's ask something fun. Let's ask if it can do what historical monuments are popular in Houston. Does anybody here from Houston? Does anyone know anything about Houston? The historical monuments in Houston includes the Houston Museum District, the Houston Theater District, the Museum of Fine Arts, and the Houston Museum of Natural Science. There's a lot. Okay, this is a lot. Yeah. Let's ask it at least like a couple more questions, and then we're gonna run the evals. Take a look at the evals. So if you have questions you want to ask the LLM, drop them in the chat. I see you have a lot of questions for me. So OctoAI provides API endpoint with an open source LLM. Use it instead of Hugging Face itself. Yes. So Hugging Face doesn't give you access to open source LLM endpoints all the time. Like I think it has some, and I think it has some that you can download some of the actual open source LLMs and you can run them locally. But I'm not sure it has API endpoint access. I usually use Hugging Face for my embeddings model. So if it has access to LLMs, that like it might. I'm not really sure. Let's see. Let's ask it something it probably doesn't have the answer to, or it's going to hallucinate. Let's ask it about what's a city it doesn't have in here. Vancouver. Okay. When was Vancouver, Canada established? Let's see if it's going to give us an answer, if it's going to hallucinate. Oh, that's not a good sign. It's taking a long time to run. Okay, so here's where you know that the LLM is hallucinating. So let's actually see if we can kind of play around with this. So let's take the temperature down to 0 and see what happens. If I take the temperature down to 0, will it make up an answer or not? I wonder if this is actually included in one of the texts. That might be interesting. We'll see. We'll have to see. No, okay, so it still hallucinates that. So that's shows you that Llama 3 doesn't have very strong guardrails around this kind of stuff. Let's ask you something totally out of context. Where is the best food in the world? Let's see what it says. You can find the notebook. I will send the notebook. Actually, I'll send it to Anna. She can send it to you guys. Anna says orange. The Golden Gate Bridge is orange. It's actually red. Oh, what the hell is this? The best food in the world is in Copenhagen, Denmark. I don't believe this. This is definitely like a hallucination. All right, so now we're gonna run some evals. This takes a while. So let's import all this stuff here. So in Phoenix, there's a bunch of different evaluators. There's the hallucination evaluator, there's the OpenAI model, there's the QA evaluator, relevance evaluator, and of course, a way to run evaluators. So basically, this says we're going to use OpenAI, which is why we got OpenAI in the first place. This tells us if something is hallucinating. This tells us if it answered the question and how relevant the answer was. So get QA with reference. Are we going to reference something to make sure that our questions are answered from the documents? And get and retrieve documents. This is how we retrieve the documents. This is how we get the document evaluations, span evaluations. This is basically how we're doing evals on what we're retrieving. And now what we're going to do is we're going to get, we're basically going to use the tracing to get these QAs and then use the tracing, the client, to get the retrieved documents. And we're going to use GPT. Oh, yes, I should run this. Okay. And we're going to use GPT-4 Turbo. We're going to create the hallucination evaluator, the QA evaluator, and the relevance evaluator. And we're just going to run these evals. So we're going to use the queries. So queries DF is actually generated from the client. These are data frames. These are pandas data frames. This is just how Phoenix does this. We're going to get the correctness eval, which will tell us if our answer was incorrect or correct. And we're going to pass it these evaluators. And then we're going to ask it to provide an explanation. And we're going to do the same thing with the relevance. So you'll see that relevance runs on the retrieved documents and not just the queries. And that makes sense, right? And then we're going to log all of these under hallucination, QA correctness, and relevance. And this should take like a minute or so to run. So while this runs, I'm going to take a look at questions. Is this lab available for labbing? Okay, yeah. So Anna has just sent the GitHub in the chat, so you can see where the where all of this code is. Is updating the chunks content possible in VectorDBs, or do we need to recreate the embedding for updated version of the document and delete the previous embeddings? So you can update. There is this thing called upsert, which allows you to basically delete and reinsert things. But in that case, you have to kind of know the ID of the data that you're inserting. And so it's a little bit, it requires a little bit of finesse, but you can do this. Okay, let's see how this is running. Ooh, wow. Another 30 seconds. It's taking a while to run evals. I guess we did run quite a few evals, so. Oh my God, there's a lot of evals to run. Okay, let's see. Are there any questions? Yeah, so the way that, so someone's commenting on like how you can update the vector embeddings, and like the way that you would actually have to do it is that you would have to have access to the IDs of the vector embeddings themselves. And so in LangChain so this is actually a piece where you may not want to use a framework, because you can do this directly in the vector database. When you have access to a vector database directly, you can typically get this kind of information. But with things like LangChain or Llama Index or any other like thing that connects to your vector database, you may not be able to get this immediately. Wow, the fire alarms are still running. It's been like, they've been running for like almost an hour now. It's just been like continuously running like these like random tests. This is like the wildest thing. Looks like we're still gonna have a couple minutes to wait here while these evals run. But since we're done with the code, I'm going to switch this to the tab the uh, with Phoenix, so we can see this as it updates in real time. Someone asked, would you productionize LangChain, Llama Index, or semantic kernel? It's just going to depend. Like, it's going to depend on what you need. It's going to depend on what you're doing. Like, semantic kernel is like C#, right? Like, it's like LangChain and Llama Index do different things. LangChain is good for chaining together different outputs. Llama Index is really good for combining data with LLMs. But I mean, right now in all of their states, they're a little bit too bloated to kind of run for me. But I've heard that the cloud versions are coming, and the cloud versions should be nice and easy. So I'm not entirely sure. We'll have to see, because it's still very early days for, I mean, all of these frameworks, all of these companies. It's very early days for everybody right now. So it's hard to say like what these tools will look like in the near future. But for now, just don't really know. Let's zoom in on this Phoenix stuff. And so we see that the evaluations are not here yet, and we'll see that these took a long time to run, probably because let's see if it records the difference between these, right? So, oh, hey, the evals are in. Are they done? Oh, they're done. Oh, hey, cool. Okay, the evals are in. You'll see that they updated live. So 3 out of 5 of these hallucinated, and then only 2 out of 5 of the answers are correct. So let's take a look at these answers. So incorrect. When was Vancouver established? It says this was incorrect. Okay, so it's probably going to say that it's incorrect based on I told it to act like a tour guide, and this is the input. Okay. Vancouver established in 1793 as the town of Granville, blah, blah, blah. The reference text does not mention Vancouver at all. So therefore, it's impossible to determine whether it was correct because it does not align with the information available in the reference text. So this goes back to the question that someone was asking earlier. Like, how do you make sure that you can only access the question answers in the RAG? So this eval stuff allows you to kind of do that. It allows you to say like, oh, this was not correct. Like, we can't use that answer, right? And it's hallucinated because it asks about Vancouver, Canada, and Vancouver, Canada is not mentioned in the text. What is the best food in the world? It says this is a factual. It says this is factual hallucination, and QA correctness. Oh, let's see how this actually ended up running this then. What happened here? Oh, wow. Okay, so the prompt got a lot of different inputs and outputs. So let's see what it retrieved. So when I asked what's the best food in the world, it retrieved this document on cuisine. Oh, so actually Copenhagen has this thing in its Wikipedia where it says it's the most of any Scandinavian city, but increasingly recognized internationally as a gourmet destination. And then where else does it say this? Berlin. But Berlin doesn't say anything about Copenhagen here, probably. Okay, so there's a lot of things about Michelin guides in these Wikipedia entries, which is really interesting. It says Chicago, completely unrelated. Yeah, because Chicago doesn't have good food at all. Okay, where was this question? Oh, yes. Okay. It says it's factual because it's recognition of Noma as the best restaurant in the world of multiple years. Oh, I didn't know that. Okay. I didn't, you know what? I didn't think that Copenhagen would have, I thought this was going to be marked as incorrect and hallucination, but I guess not. Supported by the reference text. Number of Michelin starred restaurants, recognition of Noma as the best restaurant in the world. Okay, so apparently that's true. What the fuck? Um, what historical monuments are popular in Houston? Hallucinated and incorrect. So let's see why this was hallucinated and incorrect. The question asked for popular historical monuments. The answer provided lists blah, 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 blah. The reference text does not describe these locations as historical monuments, rather as cultural institutions. Okay. So interesting. So, ChatGPT is differentiating between cultural and historical things here. Let's see. Hallucinated, incorrect. Hallucinated, incorrect. Okay. Yeah, we knew about these. It says the Golden Gate Bridge is a good monument to visit. It's correct. Anna doubts that it's orange. And I don't think it's really orange either. Like, I don't know, man. I'm in San Francisco right now. I don't really think it's orange. Okay, let's see if we have any questions here. It's not orange. I will die on that hill. Open source vector store with both Python and TypeScript SDKs. Just use Face. FAISS. That's probably the easiest one. I mean, like, I think all of the vector databases do, like, Weaviate, Milvus, Quadrant, Pinecone, whatever. I think they all have these interfaces, but Face is free. It's easy. It's fast. They're all built on Face. You might as well just use it. Are the models responsible for creating vectors and producing the embeddings the same for the LLM? So when you use like LangChain or Llama Index, you pass the embedding function in, and the embedding function gets used for all of the embeddings to work with the vector database. When you do it yourself, you can just ensure that you're using the same model embedding, and you just put it in your workflow that you embed with the same model every time. The embedding model and the LM don't have to be the same. But the embedding model that you use to embed and store data into the vector database has to be the same as the embedding model that you use to embed and query data in the vector database. Someone asks Face or Chroma DB. Easily Face, dude. Chroma's like literally like 100, like Chroma's like a worse, I mean, not a worse version of Face. That's probably too mean. Chroma's like a Face wrapper, okay? Like, I don't know, man. Like, it's heavier, and it's like does the same thing. So Face, hopefully the Chroma people see this, and they reach out to me and they're like, yo, what the hell is this? And then like maybe they'll tell me more about Chroma. But as far as I'm concerned, it's like a Face wrapper, and Face has faster development. A lot of, it works pretty much on everything. So okay, I think that's it. So unless there's any questions, I think we can call it a day.